In this presentation, we're going to quickly have a look at the Anderson-Darling test. Now, this is a test for normality. Essentially, we want to see is the data set normally distributed or not. So, we'll have a quick look at the statement of the null and alternative hypotheses shortly. This test is used in Minitab graphical summaries quite a lot. Okay. And also in Minitab normal probability plots as well. Okay, so it's up in the top corner. Usually what you might see is a AD test statistic and a p-value. So it's usually part of both. So just watch out for AD. Okay, and what you would be given there is the test statistic, but really what you should be looking out for is the p-value. So where you see AD, the only thing really you should sort of think there is I'm in the right area of the output. So, but what you're really looking at is the p-value. So the null hypothesis is as follows: the population for which the sample is drawn, okay, so really we're talking about the population, not the sample, is normally distributed, okay? And the alternative hypothesis, H1, is that the population from which the sample is drawn is not normally distributed, okay? So just watch out for that there. The null hypothesis is that you are normally distributed. A lot of people, so essentially, usually null hypotheses are the absence or something, or the negation of something, or the equality. So essentially this is sort of hard to sort of express this null hypothesis in the usual sort of context of absence or negation. Okay, but essentially that just remember that. Usually statistics works, so starts off at the basis of normal distribution for a lot of its procedures, and you just check if it's not normally distributed. So is normally distributed. Okay. You also, what would happen there is you probably would be relying on other sort of procedures to remind you what to do. So anyway, what we do here is we interpret the p-value. So you should be given this in your somewhere in your output. So essentially AD, you might get some number there, and then just beside it p-value. So usually it's up in the top right of the graphical output. So essentially what you do there is state your significance level, and we'll just go for alpha equals 0.05. The Anderson-Darling test, AD test, let's get used to AD, is one tail. So essentially you're just comparing against 0.05. So is it less than 0.05? That's the key question really. Okay, so let's have a look at a few examples here. Less than 0.05, yes, reject null. Okay, so not normal. Okay, or well, that's not exactly what we're saying. Essentially, we have enough evidence to say that the data set is not normally distributed. Okay, we might have a type 2 error. That's another story. Not normal. Reject null. Second case, is this less than 0.05? No. Fail to reject null. Now, in this case, what would happen here is we do not have enough evidence to say that the data set is not normally distributed. Remember, that's really what we're doing here. That's correctly what the hypothesis test is. Do we have enough evidence to say that the data set is not normally distributed? Okay. Now, so you'd work on the basis of normal distribution. Okay, so finally, the last one there, less than 0.05 or 0.05. This is when the p-value is too small to calculate. It just sort of says it's smaller than this. Okay, and in that case, we would reject. So just watch out for that type of output in Minitab. Okay, again, not normal or not normally distributed. Okay, that's it.